Hello everybody and welcome to another mystery box function challenge. In the purple box there's some mystery math and your challenge is to figure out what that is. You can try this out with the link in the description, and when you think you've got an idea, come on back and see if we get the same thing. All right, let's begin with a 0. Oh, so 0 gives us infinity, and I'm going to start taking notes right away. When we've gotten that, it's not really infinity. When we've gotten this sort of error from this computer, that's usually a 1 over x. There may be a couple other times where infinity might come up, but some kind of rational function. So this may be more complicated than 1 over x, but I think that's a good starting point, at least a candidate to be suspicious of. Let's put in a 1. If this is just 1 over x, that should give us 1. And we got 1/3, 0.3 repeating. Let's put in a 2. Okay, and there we got 0.166 repeating. What is that? 1/6 maybe? Um, it looks like that's going to keep approaching that x-axis, although let's go pretty far out and see if we ever dip below it. That would be a good clue. Let's put in, I don't know, 6. Yeah, and we're still positive, just closer and closer. So it looks like that asymptotic behavior you get with a rational function where the x is on the bottom of a fraction. Let's go closer in to the y-axis here. Let's put in a negative, sorry, let's put in a 1/2. We'll try negative numbers in a minute. And actually, I'm really curious what 1/3 is going to do. So 1/3 gives us 1. I think this is a big clue. Let me just try the negative numbers. So I'm expecting an arm here and an arm down here in the third quadrant. So I just want to make sure something funny isn't going on. Let's try -1. Yeah, okay. And so this is going to be sort of mirroring that reflected over the origin. Let's try a -2, just to fill that in a little bit. Yep, we're getting those same values. And if we put in a -1/2, see the same arm forming there. Yeah. So I think that what we've got here is something that looks sort of shallower. It gets closer to these asymptotes faster than just plain old 1 over x does. I think we've got that rational function. That's the base function we're working with. But there's some kind of multiplier, and in this case, I think it's a fraction because it's making this sort of a shallower kind of curve. And the reason I was interested to put 1/3 in is because when we put 1 in, we got 1/3. And so if we put in the reciprocal, we should have gotten the 1, and we did. I think what that means, because when we put 1 in, we got 1/3. Think about this. There's something times x, and we put in 1, so whatever else was multiplied by x has to make this come out to be 1/3. So I think it's a 3. So 1 over 3 times x. If you put in 1, you get 1/3. If you put in 2 here, 1 over 3 times 2, you would get 1/6, and I think that's what this decimal is right here. And then if you put in 1/3, you would have 1 over 3 times 1/3, and 3 times 1/3 is just 1, so you would get 1. So I think we've got this, and I think we've looked at enough points. I'm pretty confident I'm going to reveal it. Yeah, there it is. So 1 over 3x, and we can graph that. Get those long arms approaching the x-axis and approaching the y-axis, and they're very close to the origin because of that multiplier on the x in the denominator of the fraction. Well, how did that go for you? Did you think rational function? Let me know. Thanks, everybody.